Hello everybody, this is CodeWithShriekDj. So today I'm going to talk about our last video, which was simply about creating a pygame program where we have a purple background as a screen window and the red circle as our layer, which is simply moved with the help of the arrow key, like red, left, right, up, down. These are the variable we had in our number. This is the player position variable, which is simply the center of our circle, which is a player. Okay, and these are the controls, like uh, based upon the arrow keys pressed, it moves. Okay, as you can see, it moves fine, but it has some flaw. Let me show you. 1 2 3 4 5. Okay, 1 2 3 4. Let's go again. 1 2 3 4 5. 1 2 3 4 5. Okay, nearly 5. Okay, so as you can see, what is currently happening, it's moving faster whenever we try to move it diagonally. This is the spin window and this is the bug we are going to solve today, which is simply the diagonally goes faster. But I think we have to make the branch of our last video. Okay, so git branch 000 underscore draw circle for our last video, and I'm going to push there. Okay, so let's go with the changes. So currently what is happening, whenever we try to move diagonally, it's moving at the speed of the 424 pixel, nearly 424 pixel. It can be easily calculated with the Pythagoras theorem, which is square root of the 300 square plus 300 square here. So it should not be at here, it should be at here. Okay, so for resolving that, what do we need? We need a new variable which is called as the player direction. It's simply a 2D point like variable which stores the direction of our player and also gives a variable which can be used to normalize the current speed diagonally. Okay, let me just change this to distance. Okay. So we are going to create a variable here. The player direction is equal to pygame.vector2 and 0 0. As you can see, it's not a tuple because it stores the direction of our vector. Okay, in vector calculation it uses that. Okay, let's go with this. So it's similar to xy, where the 0 0 means the no movement at all. But if it's 1 0, it should be right, but I have written left here. I'm recording the voice after the screen recording. So 0 1 should be down and 0 minus 1 should be up as per the graph, as you can see. Okay, y-axis is increasing, so it will gonna be down. So for that, we simply need to replace this with the player pose replace with the player direction, player underscore direction. Okay, and the minus equal to distance will become the equal to minus 1, and plus equal to distance will become the equal to 1. Okay, we have changed this. We also need something else. Let me just show you what it calculating, what we are gonna calculate. I have imported the pygame, the player direction pygame.vector2 0 0. Okay, this is our vector. If we try to update the value of let me just show you magnitude first, like the a square x square plus y square 0. Okay, if I change it to 1, magnitude become the 1.414, which is okay, and y also 1.414, which is square root of 2. And if I go with the 1 upon player dot magnitude, it gives a value called 0.70, which is a number which, if I try to multiply by 424, it will just gonna give me a 300 pixel. Yeah, let me just show. Oh, see, same 420. So it will just gonna give me a number which can be used to normalize the speed of our player position. Okay, So for that we need a new functionality like the if player dot magnitude is greater than 0, the player direction should be normalized. Like it have limit of the -1 to +1. Okay. Currently, what is happening under the hood is like this: again dot vector 2, the player dot x direction dot x divided by player magnitude, and same goes for the y divided by magnitude. It's being divided by magnitude, so that's why we are checking beforehand: is it greater than 0 or not? And it's also an unitless. It does not have unit like our other variables, like the frame per second, frame per frame, like that. So let's create a new distance from the player. I think okay, let's go with whatever we have. Player speed times the player direction. Let me just write again. Okay, player direction times the dt. Okay, so dt is our float. The player direction is the vector2 type. This is the little 300 integer, and this is the vector2. We need the new vector2, and we are gonna change our player position with the distance, like whatever we distance needed. Okay, so let's go. Okay, as you can see, it's moving diagonally at the same speed whenever it's moving horizontally or the vertically. See? See? Okay, it's fine, it's fine. Let me, but uh, like the x and y should become 0, because if I did not do that, and I am not pressing any buttons, and I have moved once out player, it will not stop moving at all. So we need the resetting the direction also. Otherwise, it will just move indefinite. Okay, let me make it in a one line. Okay, plus equal to distance. Okay, and it can be also copied from here to here instead. Okay, it's being copied. Let's go with that. Okay, I'm gonna try again running this. Oh, okay, our player moving at the same speed, diagonally, vertically, horizontally, and I'm gonna commit it for like the player going diagonally result, doing first result. Okay, and there is one more thing here. As I said, the magnitude is like simply the square root of the x square plus y square. So we are just gonna change this to magnitude underscore squared. What happens? It moves the computation about the square root of. In short, it makes faster faster to compute the magnitude. Okay. Okay. It's like an industry standard. We can consider that. Okay, our player moving as expected. If you have any question related to my explanation, you can give details in the comments. I'm pushing this to a new branch. This details like the 001 diagonal result. I think I'm gonna put the link about this branch and this repo in the description of the video. You can see it yourself also. I push this. See, 000 diagonal bar result. This is the branch where we covered our current video. Okay.